Good morning students. Till now we have completed our electromagnetic wave and we have covered unit 1, unit 2, unit 3, unit 4 and unit 5. That is the syllabus of our half yearly examination. So now the next chapter or unit, that is optics. So in the starting we'll revise the things what we have done in the 10th standard. The plane mirror, reflection through a plane mirror and spherical mirrors, and then we will start the refraction. Ray optics. First of all, I revised what you have done in the earlier class, 10th standard. Light. Light is a form of energy. And the bodies which are used in the optics, the luminous body and bodies and non-luminous bodies, the bodies which have their own light, for example sun, star, glowing electric bulb or candle, fire, etc. are the luminous objects or bodies. On the other hand, the non-luminous objects like flower, table, chair, book, etc. they have their no own light. Now the next topic is the reflection of light by a plane surface. The reflecting surface, like mirror, which is coated by silver salt and protected by having a layer of red oxide. So one side is reflecting. So whenever a light ray incident on the reflecting surface, so it bounces back as shown in the diagram here. The ray which is coming towards the mirror, that is called incident ray, and the light ray which is going away after reflection called reflected ray. Here there is a dotted line called normal, and the angle between normal and incident ray is called angle of incident, that is angle I, and angle R is the angle of reflection, the angle between normal and reflected ray. The laws of reflection. There are two laws of reflection. In the reflection of light, number one, the incident ray, reflected ray and normal all meet at a single point in the same plane, as you see in the diagram. Now in the second one or second law, in the reflection of light, the angle of incidence is equal to the angle of reflection. The reflection of light is mainly of two types, the regular reflection and diffuse reflection, as you have seen in the 10th standard. When the surface or reflecting surface is smooth, the reflection will be regular reflection. If the surface or reflecting surface is irregular, then reflection will go in different direction, so it is called diffuse reflection. Now the next topic is the object and images used in the optics. In optics, anything which gives out the light is called object. For example, electric bulb, glowing electric bulb lighted candle, arrow, tree, etc. On the other hand, the image is an optical appearance produced when light rays coming out from an object are reflected or refracted. These are of two types, real image and virtual image. In the real image, the light rays after reflection of refraction are actually meet at a point and form a real image. On the other hand, the virtual image, the light rays after reflection or refraction are appear to meet to form an image called virtual image. The formation of image by a plane mirror. So here the two diagrams are shown in which the image is formed by a plane mirror. From these two diagrams, it is clear that the image formed by the object will be at the same distance as the object is placed in front of the mirror. Number two, the size of the image is equal to the size of the object. Next point is the image is virtual and erect because the light rays after reflection appear to meet. And the next, the image formed is laterally inverted. So these are some properties of the image formed by a plane mirror. The next topic is the spherical mirror. The spherical mirror, it is made from a hollow spherical glass. A part of it which is coated from one side and other side is reflected is called an spherical mirror. It is mainly of two types. One is concave mirror, another is convex mirror. So as shown in the diagram, in the sphere we have given the shaded part. So in one part it is from inside and outer surface is reflecting, and this is called convex mirror. And on the right hand side, the surface which is coated from the outer part and inner part is reflecting, this is called concave mirror. There are some important terms related to the spherical mirror, that is pole. The pole P, which is the center point of the spherical mirror, called as pole. All the distances measured from this pole and it acts as origin. Now the second term is center of curvature. The center of curvature, the center of the spherical mirror. So this is called center of curvature, C. The radius of curvature. The radius of the spherical mirror, so it is called radius of curvature. It is represented by R, capital R. Principal axis. the principal axis, the line joining the pole and center of curvature C and going outwards, and this line is called as principal axis. So these are some important terms, and another one, that is focus. So as shown in the diagram, so there are two diagrams, one is towards left side and other is towards right side. In the left side there is a concave mirror and a light ray is falling parallel to the principal axis, and after reflection it goes or passes through a fixed point on the principal axis. This is called the focus of the concave mirror. On the right hand side there is the convex mirror. In the convex mirror, a parallel light ray coming towards the mirror, and after reflection it appears to come from a fixed point on the principal axis called F or focus. Now the focal length, the distance between the focus and pole is called focal length. Generally it is represented by small f as shown in the diagram. The aperture, the periphery or the chord shown by AB, it is called the aperture, the openness of the spherical mirror. The next relation, that is relation between focal length and radius of curvature, we have done in the 10th standard. So here a diagram of it is given here. The light ray parallel to the principal axis falls on the concave mirror, and after reflection it passes through the focus in normal, which is going to the center of curvature C. I and R are the angle of incident and angle of reflection. So the distances from pole to the F of focus is called focal length F, and the distance from pole to the center of curvature C, that is R, radius of curvature. The relation is the focal length of the mirror, concave mirror or the convex mirror, it is equal to the half of the radius of curvature. Now the next is rules of image formation by spherical mirror. So in the form of diagrams for concave mirror as well as for convex mirror towards right side. So the rule number 1, in concave mirror, the light ray parallel to the principal axis always passes through the focus, while for convex mirror, the light ray going parallel to the principal axis, and after reflection it appears to come from a point, that is focus. Number 3, so light ray going through the focus, after reflection it become parallel to the principal axis in case of concave mirror, but in case of convex mirror, the light ray after reflection become parallel and it appear to go towards the fixed point focus. And in the third rule, the light ray which is going through the center of curvature and after reflection it return back to the center of curvature. In case of concave mirror as well as in case of convex mirror. The rule number 4, the light ray incident at the pole of the mirror makes the same angle equal to the angle made by reflected ray by the principal axis in both the cases of concave mirror as well as in case of convex mirror. Yes, the next topic is the image formation by concave mirror. So here a finite size object AB is placed on the principal axis of the concave mirror. So one light ray which goes parallel to the principal axis, after reflection it passes through the focus, and another light ray which passes through the center of curvature, and after reflection it retraces their path. The two light rays intersect and forms an image A dash B dash inverted. So the distances from the pole to the object, that is U, and the distances from pole to the image, that is V, and the distance from pole to the focus, that is F, the focal length. So this is the image formation. The image will be real or inverted, or the size of the image and position of the image. So there are number of diagrams that you have done in the 10th standard. So I am giving you a table. In this table, the object AB is placed on the principal axis at infinite or beyond the center of curvature, and at center of curvature between C and F, and at focus F, and between focus and the pole. So in these all cases, the nature of the image is real and inverted, except the case when the object is placed between focus and pole. The size of the image in the first case is very small in compared to the size of the object, and we go beyond, so the image size of the image increases, and in case when it is at C, the size of the image is equal to the size of the object, and afterwards the image size enlarging in the rest three cases. And the position of image in the first case, when it is at infinite, the image is formed at focus and shifted from focus towards the center of curvature and beyond C, and when the object is at focus, the image is formed at infinite, and in the last case, when the object between focus and pole, the image formed behind the mirror. Now the next is the image formation by the convex mirror. So here in this case, the image formed by the object AB is always virtual and erect, is smaller in size, and always between pole and focus as shown in the diagram.